Thank you so much. So one of the questions that I think really animates the video that we just watched is this question of how can we make sure that the set of values that are embodied implicitly and explicitly in our technology are actually aligned with the things that matter to us about the world. And in particular, I'd like to focus the conversation on one of those values in particular. And that is the value of fairness. So in the judicial system, whenever a judge needs to make a ruling on sentencing, so how long someone might be going to jail, or parole, whether someone is going to be released early or forced to serve the entirety of their sentence, one of the things that the judge needs to weigh in that decision is the likelihood that the prisoner will recidivate or reoffend. That is, what are the chances that if we let this person out back into society, they will go on to commit other crimes? And this is known in the field as risk assessment. And for many years, this was simply done with the kind of intuition or the personal judgment of the human judge. But over the last 10 years, increasingly, risk assessment is being provided to the judge algorithmically by a computer system, often a private for-profit system that does not release the inner workings of its algorithm. So in the United States, one of the most prevalent and most widely adopted systems of this kind is from a company that's called North Point, which offers automated decision support, advancing justice, enhancing community. At least that's what their homepage says. And in particular, the algorithm that they're known for is called Compass. And Compass makes a suggestion to a judge on a scale from 1 to 10 of how risky is this particular defendant? What is the risk that they will go on to commit other crimes if they're released? Now, due to the legal regulations around how this works, the algorithm explicitly does not incorporate the race of the defendant into its suggestion. And yet, an investigation done by some journalists at the nonprofit group ProPublica, which was published about 6 months ago last summer, revealed what appeared to be some weird anomalies that, at least from first glance, appeared to be correlated with the race of the defendant. So ProPublica published this story about this, and they highlighted these two defendants in particular. So Bernard and Dylan were arrested in the same year. It was 2014. In the same county in Florida, Broward County, which is where Fort Lauderdale is, and they were charged with the same crime, which was drug possession. They also had fairly similar priors. They each had one prior. For Bernard, it was resisting arrest. For Dylan, it was an attempted burglary. And yet the Compass system gave them wildly different risk scores. So Bernard was given a risk of 10 out of 10 to reoffend, which is the highest that the system can give. And Dylan was given a score of 3 out of 10, which is at the low end of the spectrum. And because this happened in 2014, we actually know what happened in the future. We know whether they went on to commit other crimes or not. And so in this case, Bernard had no subsequent encounters with the law, and Dylan, who was only rated a risk of 3 out of 10, went on to be arrested for 3 additional offenses from 2014 to 2016. Now, I think it's fair to note at this point that we shouldn't make too much out of any particular anecdotes, that any automated system, no matter how good and how sophisticated and how well calibrated, is going to make errors. And so the question is this indicative of any sort of broader pattern that should give us pause or cause us to kind of call into question the system? Now, when ProPublica raised some of these concerns that they had with the company Northpoint that makes the algorithm, they received the following response. It said the rate of accuracy for COMPAS scores, which is about 60%, was the same for black and white defendants. This means that on average, the system can correctly predict whether someone will reoffend or will not reoffend 60% of the time, and that it is equally accurate for black defendants and white defendants. And here's the part that I think is really interesting. The company said that it had devised the algorithm specifically to achieve this goal. They then go on to say, a test that is correct in equal proportions for all groups cannot be biased. And I think this raises a really interesting question. So ProPublica drilled into the data a little bit more, and they said, well, okay, it is in fact true that there is the same accuracy rate across both of these groups. But if you look at the types of errors that the system is making, is there a broader pattern to that? What do you see? And this is what they found. So 60% of the time, again, in both groups, the system can accurately predict whether the person will go on to reoffend or not. 40% of the time, it's incorrect. But it turns out to be incorrect in wildly different ways. So for example, if you look just at the defendants for whom it made an incorrect prediction, among black defendants, it was twice as likely to rate them as a higher risk than they really were. For white defendants, it was twice as likely to rate them as a lower risk than they really were. And so this has kicked off a firestorm of different articles and investigations into this algorithm. And there are papers from statisticians who refute this analysis by ProPublica. Then there are follow-up papers by other statisticians who refute the refutation. And then there are other statisticians that refute the refutation of the refutation, and so forth. And it all gets pretty far into the weeds mathematically. But I think philosophically, there is something incredibly interesting and important that's going on in this kind of a conversation, which is that a numerical analysis of this problem is allowing us to ask a really fundamental question. What is fairness? What do we mean when we say of a system that it ought to be fair? You know, Northpoint is saying, well, we're equally accurate across all these groups. And ProPublica is saying, well, yes, but you're inaccurate in different ways. And so there is this real question of, we as a society have this value, but how do we try to get precise enough about what that value means in explicit numerical terms that we can really say whether a system upholds those values or not? And just in the last 6 months, this has, there has been an explosion of interest in this area among the computer science community, which I think is very interesting. There have been a series of papers by researchers at Stanford, Cornell, Carnegie Mellon, Harvard, Google, the University of Chicago. And these, in many ways, are not the typical people that write papers about, you know, public policy and justice and so forth. But they're asking this question from a computational perspective. And so there have been a series of these papers, you know, equality of opportunity and supervised learning from a group out of Google. Fair prediction with disparate impact out of Carnegie Mellon. And one of the papers that I think is the most interesting has come out of Cornell, and it's inherent trade-offs in fair determination of risk scores. And so this group of researchers got together and they said, okay, let's try to decide statistically, mathematically, what are the statistical properties that a fair procedure ought to have. And they said it should really do three things. One, it should be what's called well-calibrated. That means that if the algorithm identifies a set of people of having a probability Z of, they use very abstract language, constituting positive instances, but in this case it would be going on to commit additional crimes, then approximately Z% of those people should indeed go on to commit other crimes. And this was in fact what we saw with the COMPAS system. And this should hold just as well when applied to each group. Now, the second criterion is that it should be what's called balanced for the positive class. And what that means is that among the people who did go on to reoffend, they should have received, on average, the same risk score. And that this should be the same across both groups. Likewise, you have what's called balance for the negative class, which is among all of those people that did not go on to commit a crime, they should have received, on average, an equally low risk score. And that this should also hold between different groups. And this is what we saw was not the case in this analysis of the COMPAS system. And so I think it's fair to say that intuitively we want a fair system to embody all three of these different principles. I think they're all reasonably intuitive, and I think they all capture something about what we mean informally when we say that something should be just or something should be fair. However, this result that came out of the Cornell group I think is quite shocking. So here's what they say. These conditions are, in general, incompatible with each other. They can only be simultaneously satisfied in certain highly constrained cases. Moreover, this incompatibility applies to even approximate versions of the conditions as well. And so this, for me, is where the plot really thickens, which is the answer that's coming back from the computer science community is that we cannot satisfy all three of these intuitive notions of fairness at the same time. And so I think this then prompts a much harder public discussion, but one that very much needs to happen, which is, okay, well, if we can't have it all, which are the values that we prioritize over which other ones? And I think one of the other really striking results that came out of this work is the reason that we can't satisfy all three of these intuitive notions of fairness has very much to do with what's called the uneven base rate. So certain people simply encounter the police at different rates. Some people's neighborhoods are much more aggressively patrolled, or they're much more aggressively accosted or pulled over and so forth. And so the research, in a way, is this very theoretical work, but it identifies the root cause in the real world, which is that as long as people are encountering the police at different rates, that you have at best this kind of loose system that can only satisfy one or two of your criteria. If we could somehow improve this aspect of the world, then it would go on to be possible to satisfy these three criteria at the same time. And so I think it's very striking that this abstract numerical work both locates the source of the root cause of the problem in the real world and offers us something of a map to how to go about addressing that. I think more broadly, as we in the 21st century increasingly deploy these automated systems that take over aspects of decision making formerly done by humans, and particularly ones that do so with giant opaque black box neural networks that can't really be scrutinized except from the outside. This question of how do we make our values explicit and how do we ensure that the systems that we're implementing embody those values only becomes more and more important every day, and I feel like the stakes only get higher. And in fact, I would say that this really speaks to some of the greatest fears that technologists have about the impact of AI on the world. And I'm not talking about situations like this, by the way, in which there is some malevolent AI that decides to, adopt as its goal the extermination of the human race. If you talk to computer scientists, the scenarios that they're much more concerned about look something like this, right? Imagine a system that appears to cater to your every whim. So you say, oh, this is great. I can ask it to fetch me some water. It knows what I'm doing. It does exactly what I want. It goes and fetches me some water. Maybe that's a little bit more than I wanted, and now I'm trying desperately to avoid getting sucked into a giant whirlpool. These are the types of scenarios that increasingly the computer science community is concerned about when it comes to AI. If drowning by a pool of automatically filled water is not your main concern, there is a different flavor of the problem that sometimes appears in the computer science literature that's called the paperclip maximizer problem, which is a cautionary story about someone who implements AI in their paperclip factory and gives it the goal of manufacturing as many paperclips as possible. And the factory then goes on to convert all of the usable biomass of the Earth into paperclips, including its human creators. And there's this famous quote that's, "The AI does not hate you, nor does it love you. You are simply made out of atoms which it can use for something else." Now, these sorts of concerns that we will set a helpful AI down this path and then regret the wishes that we asked of it. This has been one of the concerns in the field of computer science since the very early days. So here's Norbert Wiener saying, "We had better be quite sure that the purpose put into the machine is the purpose which we really desire." And here's contemporary computer scientist Stuart Russell saying that instead of pure intelligence, we need to build intelligence that is provably aligned with human values. And I think there's a lot of really important work being done in that area. And it seems to me also that a precondition for having technology that is provably aligned with human values, in order to even begin to answer that question, we need to know what those values are. And so I think we're at the very beginning of a project that I think will be one of the defining projects of the human race in the next 10 years and over the next century. And I think it's going to require a collaboration not only among computer scientists and statisticians, but also across the entire academic spectrum, people in the social sciences, philosophers, and also people who work in public policy. And I think we're just at the very beginning of this kind of grand synthesis of how to think with a newfound level of precision and rigor about some of our oldest and most important questions that we have as a species. And to me, it's an extremely important project to be at the beginning of. And I have a certain amount of optimism that if we pursue it with the appropriate amount of care, we will get to a place that looks like what we want. And I think just being at the beginning and watching these conversations starting to take place across disciplinary lines is really encouraging, and I think it's a good place to be for now. Thank you.